We're now going to look at some of the special functions that are available. Sometimes we want to not only get a reading, but also to perform additional processing on the reading. The special functions are available by opening up this screen over here. Let's have a look at the functions that are available in this case. Average is used to deal with situations where we have perhaps an unstable laser or otherwise jumpy readings which are difficult to use. By selecting average, we can have the StarLab application show us not the moment-by-moment real-time value, but rather a running average calculated over the particular time that we've selected. And that smooths out any possible jumpiness in the readings. Offset allows us to subtract out any constant background light level. For example, if we're measuring low power lasers in a room where there is background light that could affect the reading, we could temporarily block the laser, and then when we click offset, we will, from all further measurements, will subtract the background light until we deselect offset. Scale factor. If we're taking readings at various points in an optical setup, for example, the power coming out of the laser, and then the power after, for example, some attenuation factor, a filter, a beam splitter, we can place the sensor here. We could, after the filter, we could manually enter in the attenuation value, and then although the sensor physically is measuring the power after the filter, we can have StarLab display for us the calculated power before the filter. And then when we deselect scale factor, it'll go back to displaying the actual real-time power that's being physically measured. Selecting dBm would display the power in units of dBm in applications where that's necessary. For example, in telecom applications or other uses of fibers. Deselecting it brings us back to power in units of, in this case, microwatts. The normalize function would be used in cases, again, where we need to take measurements at several different locations as a ratio of the power measured at some reference location. So for example, we could measure the power coming out of a source, select normalize, and then all subsequent measurements would be displayed as a ratio relative to the value at that reference source. Whenever we click on this arrow, we reset the reference value to what the power is at that particular moment. When we deselect normalize, we go back to measurement in absolute terms. Density would be selected if we need to measure not the absolute power in units of microwatts, but rather the power density in units, for example, of microwatts per square centimeter. When we select density, we then have to manually enter the spot diameter, and we get the power displayed as power density, microwatts per square centimeter. Here is where we would manually enter the number. And if we have a rectangular spot rather than a round spot, then we're prompted to enter the height and the width rather than the diameter.